Hello BSc students. So before starting up with the syllabus, let's go through some basic which you have already learned in PUC. Okay, just will brush up and then get into the syllabus. Okay, so this is the definition. A rectangular arrangement of numbers along the rows and columns is called a matrix. Okay, and if there are m number of rows and n number of columns, then the matrix is said to be of the order m cross n. Okay, and I have given some examples. See, matrix is denoted by capital alphabets, and see, for example, here there are 4 rows and 3 columns. So this matrix is of the order 4 cross 3 or 4 by 3. So you can read it anyway. And this is the matrix X, which is equal to 5, 1, 2, 4, 5, 9. And here there are 3 rows and 2 columns. So it is of the order 3 cross 2. Okay. So these are some examples of matrices. Okay. Now moving on to the types of matrices. Zero matrix. What is zero matrix? A matrix in which every element is zero is called a zero matrix or null matrix or void matrix. So there are actually 2 other names for zero matrix, that is null matrix and void matrix. Okay, and I've given one example. See here. Here each and every element of the matrix is 0. So this is the example for zero matrix, and the order of this matrix is 2 cross 2 as there are 2 rows and 2 columns. Okay. Now row matrix. What is row matrix? A matrix containing only one row is called a row matrix. Okay. So there will be only one row. Irrespective of the number of columns, we need to just look at the row here. There should be only one row. If there is only one row, then we call that as a row matrix. Okay. See here, there is only one row and 4 columns. Okay. So this is of the order 1 cross 4. Now next, column matrix. A matrix containing only one column is called a column matrix. So it is something similar to row matrix. There in row matrix we had only one row, and here in column matrix we have only one column. Okay, so irrespective of the number of rows, here in the column matrix we need only one column. Okay, so here there are 3 rows but only one column. So this is the example for column matrix. Okay, next one is square matrix. A matrix having equal number of rows and columns is called a square matrix. See here we have 2 rows and 2 columns, 3 rows and 3 columns. So if we have same number of rows and same number of columns, then we call that type of matrix as a square matrix. Okay, so these are some examples for square matrix. Next one is diagonal matrix. A square matrix having non-zero principal diagonal elements. See here, principal diagonal element means this one. Okay, so here which starts from left top corner to right bottom corner is actually referred as principal diagonal elements. Okay, and here diagonal matrix means a square matrix having non-zero principal diagonal elements and all remaining elements as 0 is called a diagonal matrix. See here we have this diagonal elements with non-zero entries, but the remaining elements are 0. So these type of matrix, these type of square matrix is usually referred to as diagonal matrix. Okay, now next, scalar matrix. Okay, a diagonal matrix with a same element along the principal diagonal is called a scalar matrix. So this is also similar to diagonal matrix, but here the other condition which adds on is the elements on the diagonal elements must be same. Say if it is 5 here, then it should be 5 here and 5 here. If it is 1 here, then it should be 1, 1. If it is 2, then 2, 2, 2. Okay, so the principal diagonal elements must be same and the remaining all elements must be 0. So that type of matrix is usually referred to as scalar matrix. Okay, now next definition, identity matrix. So it is something similar to scalar matrix here. A scalar matrix with the diagonal elements equal to 1 is called a unit matrix or an identity matrix. See, this is an example of 2 cross 2 identity matrix. See, here the principal diagonal elements is 1 and the remaining elements will be 0. Okay, so and this is the identity matrix of order 3 cross 3. Here the principal diagonal entries are 1 and the remaining elements are 0. So this is all about identity matrix. Okay, equal matrices. See, when we'll say two matrices are equal, two matrices are said to be equal if they are of same order. So this is the first condition for the two matrices to be equal. This is the first condition. Two matrices are said to be equal if they are of same order and their corresponding elements are equal. See here, if x is equal to a1, b1, c1, d1 and y is equal to a2, b2, c2, d2, then we say that the matrix x is equal to y if and only if a1 is equal to a2, b1 is equal to b2, c1 is equal to c2 and d1 is equal to d2. If this happens, then we say that the two matrices x and y are equal. Okay. Now we'll move on to matrix operations. Okay, so first one is addition. If A and B are the matrices of same order m cross n, then A plus B is also a matrix of order m cross n, which is obtained by adding the corresponding elements of A and B. See, here we'll show how to add two matrices. Okay, if A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 3, minus 2, 1, 4, 0, minus 1, then A plus B will be 1 plus 3. So you need to add the corresponding elements. See here, if you take first row first element, then here also you need to take first row first element. Okay, so 1 plus 3 equal to 4. 2 plus of minus 2, that is 0. 3 plus 1 is 4. 4 plus 4 is 8. 5 plus 0 is 5. 6 minus 1 is 5. So this is how you need to add two matrices. Next we'll move on to the second operation of matrices, that is scalar multiplication. If A is a matrix of order m cross n and k is any constant, then k into A is also a matrix of order m cross n, which is obtained by multiplying every element of A by this constant k. So this is actually the process of scalar multiplication. See, I have taken an example. If A is equal to 1, 2, 3, 4, 5, 6, then Ka will be equal to k into 1k, k into 2, that is 2k, k into 3, 3k, k into 4, 4k, k into 5, 5k, k into 6, 6k. So here what you will do is you will multiply each and every element with this constant k. So that is what is known as scalar multiplication. And the last one is matrix multiplication. Here, two matrices A and B can be multiplied only when the number of columns of A is equal to the number of rows of B. If A is of order m cross n and B is of order n cross p, then their product AB is a matrix of order m cross p. See here, if the number of columns in the first matrix and the number of rows in the second matrix is same, then these two matrices are eligible for matrix multiplication. Okay, so and then their product AB is a matrix of order m cross p. So if these two are same, then their product AB is a matrix of order m cross p. M cross p. Okay, so here we have considered one example. See here, If A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 1, 0, minus 1, 3, here this A is of order 2 cross 2 and B is of order 2 cross 3. And here the number of columns is equal to the number of rows. Okay, the 2 columns and 2 rows. Okay, therefore we can multiply A and B. Okay, AB is equal to matrix A into matrix B, and here it has 2 rows and this has 3 columns. So the resultant matrix will have 2 rows and 3 columns. So it will be of the order 2 cross 3. Okay. So here, how we'll multiply two matrices? We first take first row in the first matrix and first column in the second matrix. So this is first row and here it is first column. Okay, so here it is 1 into 1 plus 2 into 0. So it is 1 plus 0. Next, first row, second column. First row, second column element. Okay, 1 into 2 plus 2 into minus 1. That is 2 minus 2. Next, first row, third column. 1 into 1 plus 2 into 3. That is 1 plus 6. And now we'll go to second row, first column. Okay, so it is second row, first column. 3 into 1 plus 4 into 0. 3 plus 0. 3 into 2 plus 4 into minus 1. That is 6 minus 4. 3 into 1 plus 4 into 3. That is 3 plus 12. So finally, we'll get AB equal to 1, 2 minus 2 is 0, 1 plus 6 7, 3 plus 0 is 3, 6 minus 4 is 2 and 3 plus 12 is 15. So this is how we'll multiply two matrices. Okay. Now we'll move on to second example. If A is equal to 1, 2, 3, 1, 1, 1, 3, 2, 1, find A square. So A square is A into A. So A into A. So here we have 3 cross 3 and here also we have 3 cross 3. So the resultant matrix is of the order 3 cross 3. So first row, first column. 1 into 1 plus 2 into 1 plus 3 into 3. That is 1 plus 2 plus 9. Next, first row, second column. First row, second column. Okay, so 1 into 2 plus 2 into 1 plus 3 into 2. That is 2 plus 2 plus 6. Next, first row, third column. So here also first row, third column element we are writing. So here first row and here third column. So 1 into 3 plus 2 into 1 plus 3 into 1. So it is 3 plus 2 plus 3. Next, second row, first column. So it is 1 into 1 plus 1 into 1 plus 1 into 3. So it is 1 plus 1 plus 3. So now we are finding second row, second column element. So it is second row, second column. 1 into 2 plus 1 into 1 plus 1 into 2. So it is 2 plus 1 plus 2. And now we are finding second row, third column element. So it is second row, third column. 1 into 3 plus 1 into 1 plus 1 into 1. So it is 3 plus 1 plus 1. So similarly with the third row. So finally we'll get 12, 10, 8, 5, 5, 5, 8, 10, 12. So this is all about matrix multiplication. And the last example, if there is an unknown to find. If 1x square 3 1 minus 4 2x 2 0 is equal to minus 3 minus 1 1 1. Find x. So we need to find this x. Okay. So I have just subtracted these two matrices. 1 minus 4, x square minus 2x, 3 minus 2, 1 minus 0 equal to minus 3 minus 1 1 1. So this is written as it is. And now 1 minus 4 is minus 3, 3 minus 2 is 1, 1 minus 0 is 1, and this x square minus 2x as it is. Okay, see here, and you can just see here, minus 3 is minus 3. Okay, and here 1 is 1, 1, 1. And here, since these two matrices are equal, this x square minus 2x should be equal to minus 1. So if I equate that x square minus 2x to minus 1, we have x equal to 1 comma 1 upon solving this quadratic equation. So this is all about the matrix multiplication. Okay. Now next we'll move on to transpose of a matrix. A matrix obtained by interchanging rows and columns of a given matrix is called transpose of that matrix. See here, I've taken one example. if A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then A transpose is denoted by A T or A dash, okay, which is equal to, see here, first row is now first column, second row is now second column, third row is now written as third column. So this is the transpose of A, okay, and the transpose of a matrix A equal to Aij is denoted by A dash equal to Aj. See, this Ij is actually the number of rows and number of columns in matrix A. And here in the transpose matrix, this Ji, this J becomes the number of rows and I becomes the number of columns. See, I've just written what Aij is. Okay. See here, if we consider 3 cross 3 matrix, Aij is equal to A11, A12, A13. Means first row, first element, first row, second element, first row, third element. And this is A21, A22, A23. This is second row, first element, second row, second element, second row, third element. A31, A32, A33. That is third row, first element, third row, second element, third row, third element. See here, the number 11 denotes the place of A11. Like it is in first row, first column. And here, 12 denotes first row, second column. So it just denotes the place of the element. Okay. And here AJI will be, see here, I have just exchanged. I have written this first row in first column, second row in second column, third row in third column, which is nothing but the transpose of this matrix. So here Aij is this and Aji is this. So Aji is the transpose of Aij. So this is all about transpose of a matrix. Okay. Now let's move on to next topic, symmetric matrix. Any square matrix A which is equal to Aij is said to be symmetric if Aij equal to Aji, means if any matrix which is equal to its transpose, then we call that type of matrix as symmetric matrix. See here, consider this example 3 2 2 5. Even if you take the transpose of this matrix, you will get the same. 3 2 2 5 can be written as 3 2 2 5. So it is same as this matrix itself. So the matrix which is equal to its transpose is called symmetric matrix. And similar with this, see here 1 2 2 1 2 2. 247 247 275 275. So here this matrix is equal to its transpose. So this is the example for symmetric matrix. And moving on to skew-symmetric matrix, any square matrix A equal to Aij is said to be skew-symmetric if Aij equal to minus Aji. Means if the matrix is equal to negative of its transpose, then the square matrix is said to be skew-symmetric. For example, 0 to minus 3. If you take a transpose, it will be 0 to minus 3. And if you take a minus sign, it will be 0 minus 2, 3. So if you take the transpose of this, see here, if you take a transpose of this matrix, you have 0 to minus 3, minus 2, 0, 4, 3, minus 4, 0. Actually, this is the transpose of this matrix. And if you take the negative sign, then this becomes minus 0 or simply 0. Minus 2, plus 3, plus 2, 0, minus 4, minus 3, plus 4, 0. See, these two are looking same. So, what I have done? I have taken the transpose first and then I have taken the negative sign. Okay, so this is same as this. So if this happens, then that type of square matrix is said to be skew-symmetric matrix. Okay, now let's move on to next topic, that is conjugate of a matrix. A matrix obtained from a given matrix by replacing its elements by the corresponding complex conjugates is called conjugate of the given matrix. See here, if this is the matrix A, then conjugate of a matrix is denoted by A bar, okay, which is equal to, see here the conjugate of this element is 2 minus I. Conjugate means you are just replacing the imaginary part by the negative of that, okay, so that becomes the conjugate. So this is 2 plus I, this is 2 minus I, and here we have minus I and here we have plus I. This is 3 plus 2I and this is 3 minus 2I. This is 7I, this is minus 7I. 5 plus I, 5 minus I. 0 is simply 0. 4 is simply 4 because there is no imaginary part here. We have just a real part. So it is written as it is. 5 is 5. Okay. And what is the complex conjugate of 6i? That is minus 6i. This is the imaginary part. So we have minus 6i as the conjugate of this. Okay. So replacing those elements by its conjugate forms a conjugate of a matrix. Okay. Now next topic, Tranjugate of a matrix. The transpose of a conjugate of a given matrix is called the tranjugate of a matrix. See here, we will just take the transpose of a conjugate matrix. So then that becomes the tranjugate of a matrix. See, if this is the given matrix, see I have taken the same matrix as the above. Here actually we have got the conjugate matrix. And if I take the transpose of this matrix, then that becomes the Tranjugate matrix and it is denoted by A star. Okay. Or simply we can write A bar and its transpose. Okay. Transpose of the conjugate matrix. And next definition is Hermitian matrix. A square matrix is said to be Hermitian if it is equal to its Tranjugate matrix. So if you take the conjugate of this and transpose of that conjugate, then you'll get the Tranjugate matrix. So here, if this given square matrix is equal to its Tranjugate matrix, then that type of matrix is termed as Hermitian matrix. Okay, these are some examples. Now, next definition is Skew-Hermitian matrix. A square matrix A, which is equal to Aij, is said to be Skew-Hermitian if this Aij is equal to minus of Aji with a bar. Means if the given matrix is equal to the negative of Tranjugate matrix, then the given square matrix is said to be Skew-Hermitian matrix. And these are some examples. See here, if you take the conjugate and if you take the transpose of that, you will get a Tranjugate matrix. And if you take the negative of Tranjugate matrix, that negative of the Tranjugate matrix should be equal to this. Then that type of matrix is said to be Skew-Hermitian matrix. Okay. And here you have learned this determinants in PUC, but still we'll have some revision. Okay. A real valued function from the set of square matrices to the set of real numbers is called a determinant. So it is a function which is running from the set of square matrices. So the domain is set of square matrices and the codomain is set of real numbers. So each square matrix is mapping to a real number. Okay. So here this is the method of evaluation. If A is equal to A1, B1, A2, B2, then how to determine its determinant? Okay, so here A1, B2 minus A2, B1 is actually the determinant A of 2 cross 2 matrix. And this is the 3 cross 3 matrix. Then determinant A is equal to determinant of this, which is equal to A1 into 2 cross 2 determinant of this one. See here, how you will get this thing is, see if you are multiplying A1, then you need to close this row and this column so that you will get this 2 cross 2 matrix. And you need to take the determinant of that 2 cross 2 matrix and multiply with this A1. And second element, see you have learned this already in PUC, you need to take a alternating sign. 1 plus 1 minus then plus, see here, minus B1 into, see here, if I take B1, then I will close this column and this row. So you will get this 2 cross 2 matrix. So I am taking the determinant of this A2, C2, A3, C3 like this. Okay. Next plus C1 into this 2 cross 2 matrix A2 B2 A3 B3. So it is C1 into A2 B2 A3 B3. So, and you know how to expand this 2 cross 2 determinant. B2 C3 minus B3 C2 minus B1 into A2 C3 minus A3 C2 plus C1 into A2 B3 minus A3 B2. So, I've just taken one example. How to find the determinant of this? See here. See, that is equal to 1 into, I'll close this column and this row. So it is 1 into 1 minus 2 into 0, that is 1 minus 0, minus 2 into alternating plus minus plus. So it is minus 2 into 0 into 1 minus 2 into minus 1, that is 0 plus 2. Next, plus 3 into 0 into 0 plus 1 into minus 1, that is 0 plus 1. So we have 1 minus 4 plus 3, which is equal to 0. So this is all about the basics of the matrices and determinants. Okay, in next video we'll start up with the syllabus. Thank you.